sure everything's there. Cool, I'm live. All right, let's see if the event thing got set up properly. Oh, yeah. Thanks a lot, Fernando, for the new iteration of the design. I think this looks much more clean. Right, let's see if the episode redirects, and it does. It's a pity that it doesn't actually give you enough time to read the description. It just jumps into the event. But here we are. Okay, let's give people a second or two, since you're going to be jumping straight into the middle of the stream. So, setting up my battle station here. Manage stream. Cool. Mobile phone set up. Okay, look. Making sure I'm telling the right people that there isn't a right person or people to watch the stream, but the people that asked me to remind them of it that I am live. All right, I guess we can get started. So, welcome to another instance or slash episode of Reasonable Coding. Today we're going to be talking about command line tools and the Cmdliner framework for building them. Where's it here? Cmdliner it's a library really built by Daniel Bünzli. If I manage to go to the Bünzli, yeah. He makes amazing software and it's mostly camel. He has a lot of libraries. You should definitely follow this guy and have a look at some of the work that he's done. It's really top notch. And it's a library that lets you um, through a, let's say, very, very functional programming minded way, lets you build command line applications. In that sense, it lets you handle terms and arguments for your program terms, where each one of those terms is going to be an action that a user will be taking within your command line application. And it could be, for example, git stash or git commit or make build or yarn start and so on, or npm install, right? And it helps you by not only making sure that the arguments get parsed in the right way. So if you need a number, you get a number. If you need a float, actually you get a float. If you need a string, you get a string. If you get a boolean, you get a yes or no, and so on. But also helps you use this type information to direct the code, to direct each one of the commands that you're going to be running. And by that I mean the commands that your user will be typing, to direct them to the right functions inside of your program. And on top of that, because yes, it does pretty much everything you'll ever need for command line tools, it will help you build not only syntax errors, but also help messages and manual page generations. So today we're going to be digging digging a lot around the documentation, trying to make sure we understand how is it that it works internally, but also we'll be putting the knowledge that we gain from reading into use through a small example library that we've been working on from the past live stream. The past live stream was about asynchronous and parallel programming. We didn't quite get into the parallel programming part, but we did get into the asynchronous part, and it was using a library called LWT. Oxygen, LWT. It's this one. If you want to take a look, please just go into videos in Twitch. I think I'm new to Twitch, so I might just show you around as well, just to show myself where things are. And here you'll see the reasonable coding 008 when you do like all videos. There's not that many. Yeah, number 8 is asynchronous and parallel programming with reason. Oops, that probably should be with LWT. But yes, have a look at that stream. You'll hopefully you'll learn about how to do that kind of programming with Reason and OCaml natively. And the outcome of that particular stream was this tool called Oak. Oak is a tree-like tool built in Reason Native. If you have used GNU, the tree tool, and it's not from GNU. I keep saying that, but it's just not. If you have used it, then this should be familiar. If you haven't, then, well, let me show you. So tree is a tool that lets you inspect a file, a directory tree. Literally lets you go through the whole thing. So if you run tree here, you'll see that in this particular project, it will say there is a top level folder, and then there is a small branch here that takes into this leaf, and so for another branch that takes you to plan, and that's how you have the root of the tree, right? You can see the line there in the middle, and all of the branches, and some branches are pretty strong and have a lot of sub branches and have a lot of leaves. They have a lot of roots as well, and so on. So you can see the whole tree structure. However, and for the purpose of being able to finish the tool in the scope of the last live stream, we decided to scope out the part that does the pre-printing and essentially just print the paths to each one of these files, which means this tool becomes a lot more like find dot that just lists a bunch of files. And you may notice that there's a lot of Git stuff that didn't appear before with tree, and that's because tree is going to be ignoring the hidden folders that begin with a dot. So you'll only see those things if you do tree.a, I think. Yes. And then you'll see all of the Git stuff. Hopefully this makes some sense. Anyways, so we built Oak, and you can definitely install and run Oak, even though it's just a toy tool, by cloning the repository, and then the makefile has some useful targets. It has a target for building the project, and it has a target for installing. And you can also use Dune directly if you feel like. Dune is the build tool from the OCaml ecosystem that works perfectly fine with Reason as well when you use Reason for native development, which I encourage you to give it a shot. So essentially, if you have the repository, you can run make build install, and this should make a build, and it's insanely fast. And then you should try to install it, everything. And actually, I'm just gonna, in case I forget, I'm gonna put everything in silent mode. Okay, so before we jump into the code, and we will do a small review of what Oak is doing immediately after this. Let's scope out a little bit of the work that we want to do today. We have about 2.5 hours maybe to do it, so there's no hurry. We'll take our time. We'll go through the documentation. We'll try to gain some insight of how some things are made and why some things are made in that way. Cmdliner is a tool that requires some understanding of applicatives. It's not necessary to know what an applicative is. If you like category theory, please Google that, and you'll be amazed at the amount of material out there to learn. I can recommend specifically Bartosz Milowski's stuff. He's really good. If you can get a chance, get your hands on his book, then do so. But okay, we'll do some scoping now. We want to add some flags. What do I mean by add flags? I mean that right now Oak doesn't know of user input at all. It will always take the current directory and show all of the things inside. And if you're curious, we can just sort the lines. Actually, we can just count the lines, and we should get a similar result to find. And we don't, and I wonder why. I think we messed something up somewhere. But it has happened before that the checksum of both is the same, which is very curious, especially when we sort unique. Right. Okay. So clearly, Oak is repeating some folders here. If we do sort -u, then we get the same results as find. For the time being, we'll leave that bug in there. The things that we want to add to Oak are not necessarily affected by it yet, but they may. So let's have a look. If you call Oak with another path, like I don't know var, it will still do the same thing that it did without any of the parameters, and you can't really just call it with help. It just ignores anything that you give it. So for those purposes, we want to add some flags. We want to add a verbose and a debug flag to be able to show a lot more output, right? Not only to show, hey, we're going into a directory and getting out to the directory and so on for debugging purposes, but also we just want to be able to show, for example, a summary at the end. And if you have any ideas of any flag that we could add, this is a perfect time to pitch them. And if you don't, then that's perfectly fine as well. We're going to add a help flag, so we can say, I don't know how to use this tool. Please tell me how to use it. And it should just tell you, right? It should work a lot like when you do git help, and then you get a help like this. Or, I don't know, like cactus help, and then you get help like this. But we should get some form of help somewhere. It would be very nice to be able to limit the depth of the directories that we're going into, so that when we do oak, and if we do something like a level 2, it really just shows me 2 levels rather than all of the levels ever. And it'd be nice to get some colors. To be honest, now that I think of it, something that will be even nicer than getting some color will be able to use like a git ignore file. So we can say, oh, all right, it looks like we should be ignoring whatever is in my git ignore file, which is the build folder and the .merlin file, right? And of course, if we're using a git ignore, then we can also assume that you want to ignore the .git folder. So I'm going to put this in the middle, and then nice. Xavier Villa is telling us that he would also like that. Okay, cool. And so I'm going to put it here like use git ignore. And then this should ignore stuff in git ignore and .git folder, which I think will make this usable. Not that we are intending to have a usable tool right now. This is just for learning purposes. But in the future, if you want to do a tool that ignores stuff for a git from a git ignore file, then at least we already have an idea of how to do it. Now, for those of you that want to know how we're going to be implementing this application will be completely synchronous and blocking, which means we will not use LWT now. We will be focusing on adding new flags and configuring the behavior of the tool, not making it concurrent or parallel or faster. We will dedicate a different stream sometime in the near future to do profiling and to do optimizations, performance optimizations, and we will definitely have a separate stream as well to fulfill the promise of the last one that said asynchronous and parallel, but only could give us async as an example. So we will have a parallel programming in Reason sometime soon, which I think would be a lot of fun. I think parallel applications that run in multiple processes and have to communicate. I guess are really interesting to work with. Okay, so this is sort of the sketch of what we want to do, right? All right, and the last thing that I would like to do is to give it a path from where to start, so that I can call oak and source, and then it just lists stuff inside of source instead of everything in the current directory. To do the same thing right now, I would have to, I guess, cd source, and then I will do oak, right? And then I would do go back, which is a subpar. We would like to do, source or just oak source and just get the output from there. Cool. So first things first, let's go into Cmdliner, the documentation. And if you're following along with your computer and you're not just watching the stream, the URL, I'm going to paste it on the channel so you can also open it and have a look. And I'll leave the URL for the repo as well so you can clone it and try things out for yourself if you want. And worth mentioning, there is a branch and a pull request where we can see the code and how the refactor for making everything asynchronous will be like. It doesn't necessarily, you can see the plan here that we had, and you can see the refactor of the code from the left to the right. It's a little bit more code, but considering that it's completely asynchronous, it's I was moderately happy with it. After talking with some of the authors of these libraries, I learned of much nicer ways of doing these things. So in the future, we will definitely be improving upon it. But have a look at it, take a minute, clone it, and I'll be right here. I mean, I need to drink some water. Oh, and if the audio is not good enough, I mean, I can do much about the quality, but the volume, for example, I can raise or get down if you think that, oh, this is super low. Same for the video quality. So anything that you want to tell me, just comment it out, and I'll get to it in a second. I'll leave everything. Yeah, I'll leave this here. I'm gonna be tweeting that we are live. And I don't know how to do this. Twitter. I am so new to Twitter. It's embarrassing. Now, live now at https:/twitch.tv/ I do not know why Apple thinks that in the middle of my URL it should uppercase something for me. So live now, coding, RC009. And boom. The cat is out of the bag. All right. Going back to the live stream stats. Awesome. The volume could be a touch higher. Absolutely, I can take care of that. I think here I am actually going down. I don't know if this is too high. It's getting into the yellow bits. Hello. All right. Let me know if that's a little better. Okay, cool. So let's get started. We need to make sure that first of all we have the library. So if you're following along, we can install with opam, and we can do Cmdliner. And I already have this library, so it will tell me, oh, it's already installed. The library name is Cmdliner, Cmdliner. I think you pronounce it Cmdliner, that's how I pronounce it. I'm not entirely sure. So Uh, Now that we have it installed, let's make sure that we include it in our binary build file. So, okay, maybe to do this, I need to explain a little what the setup of the project is. So the old project is very straightforward. I'm just going to open the source. It has two modules. One is called bin, which is the binary that we execute, and the other one is called oak, and this is the module that has all the business logic. So essentially, all of the work happens really in this module, and this module just takes care of the CLI. Um, I've seen this pattern around of having bin as a module in other libraries, such as ODoc, for example, the OCaml documentation generator that also works with Reason, by the way, and BuckleScript. So have a look at BSDoc if you're interested into that. And each one of these folders has this tiny Dune file, which is a file that says how to build this thing and what the name of this module will be, and if it's an executable, what name it should have, and so on. And also what dependencies it needs. So if we open this thing, if you go bin Dune over here, we'll see that it says, oh, this particular folder, source bin, right, will yield an executable with name main. And this is a little confusing, but essentially it says this should be the main entry point or the source of this executable. Now, I'm not an expert in Dune. I know enough to get around, I guess. Um, so if any of this is wrong, just let me know and we'll correct it on the fly or afterwards. And you can tell it that the executable will have a public name called oak. For those of you who like Lisp, you'll recognize the syntax is for type Lisp. It's a very familiar syntax for them. It's called S expressions, and the OCaml ecosystem is full of amazing tools for working with it, for reading it, writing it, for processing them. All right. And as libraries, we say we will have our library called Oak. That was we saw before. It's right here, sitting on side by side. Now, if you open that small module, Oak Dune, you'll see that it says that there will be a library and the name should be Oak, and it has some dependencies. Now, these dependencies right now don't matter that much to us. Okay, so in the libraries here, right, we want to add the new library that we want to use, and that library is Cmdliner. So that runs, that compile, perfect. You'll notice that my setup is a little bit uncommon if you're not used to working on the terminal very often. I'm running Vim on the left panel, so everything that you see here, right, is Vim. This is another terminal, right, and everything that you see here in this yellow part will be us running the program and debugging some things. And everything that you see here on the little one will be us, well, actually, it will be the automatic building system. And the automatic build system is started with make watch, which is no magic really. If we go into the make file on the left, you'll see that make watch just calls Dune build and it says watch. And I like make files, so I'm going to use make watch. What Dune build does is that it will build everything in the project, and watch essentially retriggers a complete build, right? For every file system change. This is interesting compared to other build systems that do incremental builds by keeping state in memory. As far as I understand, all of the state that Dune has is on disk, and it rebuilds everything that it has to. So if you have to rebuild one file, then it rebuilds only that file. But if you have to rebuild all of the project, then it rebuilds all of the project. It's normally very fast. You'll see that I save a file, and almost immediately we see either success or an error. So we will be looking into that little window, right? Every time we have some errors. For example, if I make a typo here and instead of calling the function run, I call exec and I save, boom, immediately tells me, oh, this might be a little hard to read at first, but you'll find that you have a file everywhere that says the line and the characters. And this is really, really useful because you can just say, okay, if I'm in bin, I'll go to line 1 and take me to character 8. And then it says, all right, that's exactly what I was looking for. Unbound value oak.exec, so this is the error, and it says have errors. If there's more than one error, we'll see it here, and then we can tackle one error at a time, saving the file and getting the results out and so on. I think it's pretty good. I have not invested that much time into setting up this flow. So if you're interested in working with Reason or OCaml, just have a look at how Dune works. You maybe will have it in 3 different small windows on your screen instead of in one window that has everything packed together. But you know, potato, tomato, it should be the same thing. Okay, so let's begin. How the hell do we build a command line tool with Cmdliner? And the easiest way of knowing that is going into the documentations, Cmdliner, right? And I mean, normally it is. I'm gonna make this a little bit bigger for those of you watching on your phone so that you don't have to squint too hard. And it says, Cmdliner is a declarative definition of command line interfaces, provides a simple compositional mechanism to convert command line arguments to OCaml values and pass them to your functions. Essentially, it does the parsing for us. As long as, well, not quite. It lets us tell it how to do the parsing for us. The module automatically handles syntax errors, help messages, and Unix man page generation. That, in case you're wondering what the hell is a man page and why does it man in there, this is just short for manual. It has nothing to do with gender or sex. And the Unix man pages are these things, man git. And I'm gonna make this full screen now, so don't worry. It's a very, very dense source of information that documents commands very like essentially exhaustively as far as I can tell for most of them, and it it's not very user friendly if you're normally used to googling for Stack Overflow answers and questions. But I am pretty sure that most of the things you want to do with most of the commands that your computer can execute for you will be documented here in one way or another. One nice thing of it is that you can search things by pressing a slash. We can just say print, and then it will show us all of the occurrences, and you can navigate with the key N. Anyways, you can exit them with the key Q. That's less important, but it would be nice to be able to generate documentation for a command automatically. So there's that. It supports programs with single or multiple commands like darks or git. I can't quite remember what darks was. I think it was a source control system, but darks 123, yeah, open source version control system. Written in Haskell, right? Any of you Haskell fanatics or aficionados, or and it has a theory. All right, I'm actually gonna leave this open for later. This sounds interesting. Okay, this is not very well developed or written, explained. I thought, okay, what I mean is that I expected a lot more text. That's what I meant. Okay. And respects most of the POSIX and GNU conventions. I'll let you Google those for you by yourselves. Consult the basics, details about the supported command line syntax and examples of use. All right. So these are links that we can use to get to those bits. And if you open the module to use it, it defines only 3 modules in your scope. Oh, this is nice. Okay. So this means that we can begin by just opening the module, and because the module name is here is Cmdliner, we can begin by doing something simple, and that will be open Cmdliner. And here my editor already knows that this module exists because it's a dependency. Great. And I get an error saying unused open module instead of if I had something that doesn't exist, where it would tell me unbound, or unbound essentially means this name means nothing to me, human. Okay. All right, so we have basics here, and we can go through this fairly quickly. With Cmdliner, a program evaluates a term, and a term is a value, which means your program essentially is a value, which is an interesting way of putting it because code is data. The type parameter indicates the type of the result of the evaluation. Okay, so this is a value, right, of this type, and that has a type parameter that says what the hell is returning. One way to create terms is by lifting regular OCaml values with the const combinator. So const is just a function, right, that lets us put a function that we have into the Cmdliner framework. These terms can then be applied by evaluating functional values with the dollar sign. So essentially, whereas we normally would call this function revolt by calling revolt and then parentheses, let's actually write this down so we know what it looks like. For example, let revolt, right? It will be something like this, and I think we just have print and line revolt. I'm going to comment this out for a second here. So we compile and it works. We would normally call it this way, right? You have a function called revolt, and then you call it like that. To be able to use this with Cmdliner, we need to put this function, right, this bit, without parentheses, into something that Cmdliner has complete control over. And to do that, we use the const function. So you will mind a little the OCaml syntax, but I'll do the translation, and hopefully it will be clear enough. So we have the term module here, and we're opening that module so that we get access to the const function and the dollar sign, which is which essentially is read as apply symbol or functions. So if we were to call revolt, we would say something like term, and then we'll say const revolt, and then you can do that. Right? In OCaml, it will be like const revolt, but in Reason, we just add parentheses around of our parameters. And then we have access to this operation, which is an operation not unlike when you have 1 plus 2, right? This is an operator. It's a function that takes two variables, one on the left and one on the right, and does a very, very specific thing. The compiler normally defines it something like this, A, B, and then here's some internal compiler gibberish that will turn this thing into the addition of two numbers. But you, as a normal user, you just use the operator. The nice thing about them is that they make possible. Okay, I'll use an example instead. You know how normally, if this was a function, you will call plus and then 1, 2, right? And then if you wanted to add something else to this, you will say plus, and then this result 2, 3. And then if you wanted to add something else, you would do plus, and I know this is getting really hard to read, right? 4, and so on. But it would be much easier if you just could put the function in the middle of this numbers. So like 1 plus 2, and then the result plus 3, and then the result plus 4, and then you let the compiler turn it into this ugly mess by itself. That's essentially the same thing that's going on here. This is a function, right, under the hood. And we have an operator that operates in the middle of the two numbers, right, instead of before the two numbers, which is called an infix operator that lets us write a lot of parameters here. So we'll take a look at how do we lift this parameter, which is the unit element. And we lift it by just saying constant and then the value. Okay. So this thing here should give us something that Cmdliner can understand. So let's see what the type of revolt is. And this is the part where I excuse myself, because whereas in most of your editors, you will normally find the type information in some beautiful comment-like line that you can't really access, but it's visible right there, like this. My editor, Vim, which I love, but it's sometimes a pain in the ass to work with, shows me the type at the bottom left of the screen. So somewhere around here. Let me see if this works. Nope, that didn't work. If you follow my mouse, you'll see that somewhere around here, it says unit to unit. And this is the type of this function. If you give it a unit, which is this parenthesis, it will return you a unit. It will return you, the output of this thing. So if we check this thing, we can begin with a function that goes from unit to unit, and then we lift this into some t. In OCaml, normally t stands for the type, the main type of some module. It's very common to have the module carry the weight of what it means, rather than having verbose type names. And in this case, the module is called term. So the type T inside of the module term is the main type for working with terms. So in other words, Some other programmer in another languages might have said type term equals blah 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 blah. But in OCaml, you normally just say the module will be term, and there will be some type, so well, that type will be T. And it makes all of the signatures look like this, which could be worse. From context, it's fairly easy to understand what is going on, but it takes some time. Sorry. I will rephrase that. It's fairly simple to understand. There's not a lot of types called T in that context. There's just one, but it's not necessarily easy. In fact, if you've never seen it before, it might be really hard at first, but then you get used to it because it's such a simple thing, and then it becomes easy over time. If it was complex, then it might never become easy, but it's simple, so it becomes easy over time. And then we have on the other side this this function, right? The function const that we are applying to this empty tuple, the unit element. And when we apply it, we get a term of unit. And then we have this function in the middle that takes on the left side a term from a unit to a unit. And on the right side, it takes a term of a unit. And if you apply it together, boom, you get a term that returns unit when you execute it. This might be complete gibberish right now, but hold in there, hang on, and once we get this up and running, it will be much more clear. Or so I hope. So we have a term. We can store this into a variable, right? Let's say that this will be, let's just copy the example essentially, a revolt term. And the function revolt, and then we have the revolt term. It's worth noting that this over here looks a lot like our application's code, right? And this over here is essentially our CLI code. So this could as well be in different modules, and it could be very nicely split. Now, the next thing that we need to do is evaluate the term, right? To be able to essentially execute our code. And terms, as it says here, are evaluated with a function called eval, which is inside of I just saw the comment that darks is formalized or something. Well, terms are evaluated with Cmdliner eval, yes. And okay. As it seems to be, when you evaluate a command, you give it a tuple, so you give it two things at once. You give it a term to evaluate, and you give it some information about that term. In this case, it seems to be that this is a name. We'll take a look into what that means. And after we get the result of this, we are calling the result of this with term.exit, which I assume finishes the execution of the program. If you've never seen the symbol, this is the opposite of the pipe operation. So if I write that thing, we'll get to it in a minute, and I'll explain what it is. All right, so we need to call term.eval. Cool. So if we do term.eval, we can see the type of this thing, and we'll see it has a lot of options at the bottom. Most of them seem to be optional parameters like the help or the error formatter or whether to catch something. I don't know what that is. And the environment that we're using and the list of arguments that we'll be passing in. But the last one is not optional. And this is a tuple that takes a term of some value, right? And it gets an info. We have a term of some value. We have a term of unit here, so we can pass that in there. We can say, all right, the first element of this tuple will be the revolt T. And the second element of this tuple has to be something called term.info, right? Sorry, the auto formatter will do things for me. So if you see the code changing magically all of a sudden, then I apologize, but that's the way we keep the code neat and readable by everybody, or unreadable for everybody. I don't know. It depends. Okay, but info seems to be a function. We see there on the right-hand side that we have an error in line 9, so that's line 9 over here, right? And it's in character 21. So if we go to character 21, we'll see that it begins in term info, and it says this expression has type blah 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 blah. This is a very long function with a lot of arguments, but what we really want is a term.info. All right. Naturally, if we look at the signature, we'll see that it has a lot of optional arguments here, and then at the end it gets a string. And if we call it, it returns a term.info. You might be wondering, what? Why is there a thing called term.info that returns the thing called term.info? And if you're surprised, it's because in a module, right, you can have a type called f, right, and you can have a function or a value called f as well. Because these live in two completely separate namespaces, right, you can definitely do this. So this makes it very nice sometimes to make a function, right, that will construct types of the same name. Like in this case, term.info is a function that if you call it with a string, and we'll use revolt as an example, it will give you whatever you're trying to build, which is an info. It's not unlike constructors in other languages when you would do like, I don't know, my class name, and then you put some constructor argument here like revolt. If this was something like term info, right, then it would be a little less weird for some people. Okay, so if we execute that, boom, great. Now this thing turns out to be a result. But we saw that we had this weird thing, and then a function called term.exit. So let's see why we need this. It doesn't seem to tell us. It goes straight into what's going to happen with the program. All right, so if it builds, let's try to run it. And we can run the let's say the development version of our tool by going into the build path and going into default. And this is normal in Dune, or at least this is the path that Dune will normally use. And inside there, we can find our file by using the same path that we have in our code. So we have source, bin, and then main. If I run this, it says revolt. Great. Which means we executed the program and it executed our code and we run the thing. Now I'm curious why we need the term.exit. So I'm going to open the term module in a different file, and we're quickly going to search for exit. And it's actually undocumented. Interesting. Oh, okay. Right. Okay. So this will actually make the program have an exit status code equivalent to an error or an OK. You know how when you execute a program in your terminal, like let's say I have a directory called make source. So if I call make source here, this will fail. And if I echo the last exit status code, it will be different than 0, which means something went wrong. Okay. This framework supports that by essentially applying the exit function. And this thing here, this operator, weird operator that we see, is essentially the same thing as piping the result into term.exit. So these two are equivalent expressions. Whenever you see this, this is the thing from the right is the first argument to the thing of the left. And this thing here is the thing of the left, right, will be the first argument to the thing on the right. Just read them left to right or right to left. So we can use this one, which is a little more familiar. I really like piping things into other things. And we can run the program again. And it still runs, and we have status code that is 0. So everything's good. Great, brilliant. Okay. We have our first command line tool. It's very basic. It has no options whatsoever. So we're going to go a little bit further along and try to find other examples and see how they add more things to it. So apparently there's an example here that will use 2 arguments. Actually, it's 1 argument in 2 different ways, and it will take some message. And this doesn't look very different from our, let's say, level here. and then the path that we want to use. So maybe we can start with those, and we can see how we can add them to our program. And once we get one argument running and we get the logic of the program modified by that argument, then we can continue adding more arguments. It will be, fairly straightforward after that. Okay, so we first define a term corresponding to the count option. Let's use this, and let's say it will be the level option, right? We need to, apparently there's a documentation string somewhere. And there seems to be some templating here, which is interesting. There is this name here, that's the same name here. So I'm assuming that this gets replaced in there. Okay, so let's say there will be a documentation string somewhere. So we can say, let level, and because we want to evaluate a few things in here, but still save everything into one name, we can use braces. In OCaml, you don't need to do that, but here we do. So we will say there will be a doc here, and this doc will be define maximum level of recursion. That's a terrible documentation. Let's say how many levels deep to go. Maybe that looks a little nicer. And then, wow, this is a bunch of stuff. Okay, so we clearly have a module called arg, right? That we can relate to arguments from the context. So we will say arg dot, and we'll open this module, and then we need to read this thing either right to left or left to right. So if we read it left to right, we'll say there will be a value, and the value is optional, and it's of type int, and the default value of that value will be 10. And this value's information will be the names that it will have, and the documentation name for the sample value will be count, and the documentation string for this whole value will be doc. Right? This is doing a lot, right? This is the power of the operators here. They have very restricted behavior. They do one thing and they just do then one little thing. So then you can use them to chain operations like this and get a lot of logic expressed in very little by saying very little. So let's say that we want a value, and this actually looks pretty much like what we want. But do we want an optional level? Do we want the level to be maximum, like, I don't know. Do we want a level to be maximum at all? Let's begin with value and see where it takes us. So if we begin with value, then this thing will be a function, right? That if you give it an argument of some value inside here, of some type A, it will give us a term, which makes sense because we need terms to be able to execute things. And then we have this ampersand that we seem to put in the middle of things, and the type of that is, oops, sorry, let me just add something else there. Right. The type of the ampersand is that if on the left side you have a function that takes an argument and returns a term, and then on the right side you have some argument, then you can combine them somehow and get a term out of that. Cool. The next thing that we wanted to do is declare it as an optional value, right? So we'll be saying this thing is optional, and this thing should be an integer, and the default value is 10. So we know that it should be optional and it should be an integer. So we opt int, sorry, using the OCaml the recent syntax, opt int, and we can begin by just saying 10, but let's leave a note here. Or no, wait, one second. Let's not leave a note. Let's just check the type of this thing. So the value is a function from A to term, and if we make this big, we have a term. Now, what the hell is opt? Opt is a function, right? That takes a default parameter that we can ignore, I presume, and it takes a converter. So I'm assuming that int here, right, is okay. Is a converter for ints, and I presume converters are command liners' ways of parsing information, parsing arguments, and turning them into the right data types. So when we call this thing, right, we call it with a converter of some type, and then okay, perfect. We call it with a converter of int, and then we need to give it an int. So I'm wondering if there is a converter for something else, like sum. Is there a converter for sum? Yeah, look at that. There's a converter, right? That if you give it another converter, right, it returns you a converter of an option. And this is great because we not always want to have a level. Sometimes we want to go as deep as we can. So if we wrap this in some int, then now we have a converter, and you'll see that the type signature changed. It takes a converter of optional ints. So it will take an optional int, which means this 10 is no longer a good value. Now we need to give it either some 10 or none. And I think the default, a rational default for level will be none. There is just no level, right? Go as far as you want. Cool. And one last thing to consider here is that opt, after you give it the converter and a value of the type of the converter, it requires an info. And we saw info before from line 20 here, where we said turn info revolt. So we'll chain it again as I do in the options, right, with here, and we'll just call info, and we'll see what the parameters of info are. So info, and then if we call this thing, we'll see there is a parameter called docs, a parameter called docv, a parameter called doc, and a parameter called env. And then it takes a mandatory list of strings. Wow, okay. That's a mouthful. I know for a fact, from context as well, that because this is count, and because we saw up here that the names should be count and C, that this list over here, right, will be the one used to generate these options. And I can also match, and you probably can do this too, count here to the docv count. And I think this will be the documentation for the value, and this will be the documentation for the argument itself. So let's give this a shot and see what happens when we call it. So for names, we probably want something like L or level. Sorry, we don't need the dash there. That's automatically done for us. And then we want to pass in the docv, and we want to do something like level. So it will be very obvious that that's the level number. And then we want to use the doc. All right, so if I save, this will be reformatted, so don't be scared. And it failed. We have a syntax error somewhere. Line 10, character 13, and I have semicolon there. This should be a comma, my bad. If I save, we still have a syntax error. Oh, yeah, and now it's on line 10 on character 30, and we have a colon here. This should be an equals. And now if I save, boom, we get that. All right, so this essentially tells us this is the info for this command, for this argument. This is the type you should have, and this is how you should convert it. And please take this as an OCaml value. Cool, so now how do we use this? And I'm saying cool because I can see the success down here, right? I hope it succeeded. All right, so now we will skip the message for now, and we will say, all right, just like we did before that we lifted our function into a const, this seems to be just appending the count, which we defined all the way here, right? And then the other parameter by using the apply symbol. So maybe, and this is just, maybe we just need to do level here. And if we save that, we get an error. This is the very interesting part. Why? Because revolt is a function that goes from unit to unit, right? So this will be a term that goes from unit to unit. However, Now we need to give it a type. Sorry, we need to give. We're trying to evaluate this thing with a value that is an optional int. So this no longer will take a unit, it will take some value x now, right? That when we take a look at the type of it after we save, okay, it doesn't know. It no longer is the unit type, it now is a value that represents whatever level will be. So none if there is no level passed in, or some and then a number that will be the level. In other words, if we get level here, right, then we can say hello revolt, your level is, and then we can just print the level here. But to print the level, we need to take a look at whether if it's none or some level, because sometimes we have no level, so we can do switch, and then level, and then when this is none, oops, none, then we do revolt, there is no level, and then when we do have a level, the level will be L. We can say here is your level is, and then because this is an integer, we need to convert it into a string. I mean, I can use the string of int function for that. Cool. So now we have a function that takes an optional string. What? Oh, my bad. Parentheses sometimes matter. So now we take a function that takes an optional number, int, and returns a unit. So I'm guessing that if we call it again, it will say there is no level if there is no level. And if we give it a level like 10, look at that. It already is parsing things automatically and telling us expected an integer. Yeah. All right. So we can just do level is 10. And okay, does this work for bigger numbers? Yeah. How bigger? Let's see. Yes. Okay, so big, but not that big. There you go. That's the biggest number I can manage to give. All right, but that's great because we defined in very few function calls how exactly do we need to parse this piece of argument. The best part is that our function or application code, right, is defined to work with the actual values that will be parsed. So we don't need to care about whether this is a number that's in range or not. We just need to care about, you know, some number that we receive. So here we could do we could use these numbers however we see fit. That's great because Cmdliner will take care of doing all the nasty work, taking the string, making sure that it's a valid number, yada yada. Cool. So now let's do one more thing and let's add the path. And we'll do something similar, right? Now that we know that we need to add a doc, so we'll say doc, and this will be like path from where to start, searching or listing files. And we'll say there will be an argument, and this thing will be a value, and it will be an optional, and it should be a string. And by default, we will have the current path. So by default, we'll be working with the current directory. And by putting this thing here means that our code doesn't have to assume that there is some default path. We can just say, use exactly what's being given to you. Oh, but this is kind of silly because if we have a default and it will always be a value, then our code will always receive a value, which means we can just say this will always be a string. When the user doesn't pass in a string, we will just use the value, this one, the dot value. And then we can add the info and we can say we will have a no name. How do we do this? How do we pass a path without having to use dash p or dash dash path? Let's have a look at that. But we know that we will have a path and we know that it will have a value name, that we can call path, and we will have some docs. Okay, so we can get back to this in a second because we're missing an argument, right? And apparently, there's a slight difference here. And the difference is that instead of using an option, right, we should use a position. So pose, it's a positional argument, right? It's not an argument that is optional and has a label. It's an argument that has to be placed in a certain place. So we can use pos 0 to say the first argument, I believe. Okay, so this is just describing post facto what this is saying. So we need to say that this will be the argument. And then it appears that we need to give it an empty array for all of the short names that it will receive. And that makes sense because we don't want it to be used with any flag. There should be no flags. It really looks like maybe we wanted to have a different function for this, but I don't know. This looks error prone. And I say that because it's beaten me before. All right, so instead of opt, we want to get a positional argument that it will be in position 0, and it will be a string, and the default value will be revolved. So if we save this again, boom, our tool compiles. Now we need to give this argument, this new path argument, into our revolve function. So we can again apply it with path, and if we serve, boom. This is the beauty about this framework in particular, is that it forces you to handle the parameters that you say that you will handle. So if we just told the term revolve term that we will be handling a path parameter, and the type system tries to unify these two variables together, these two type expressions, and it will tell us, hey, I was expecting something that goes from A to B of t, but the type unit is not compatible with A to B. And that might be a very weird error, but essentially it's telling us that our revolve function is missing a parameter. And this gets cleaner as you have more type information around it. So bear with us, bear with me and the framework, and we'll get there. So now we get some path, which means because we always have a path, we can always just print your path is, right? And then just put the path in there. And the path, because we said that the path argument should be a string, it's already a string, and everything is picked up automatically. If we change this to be something else like bool, right, and we say like true, I think bool there is a combinator, I can't remember, then you'll see that this thing here says, holy crap, I was expecting a bool, but you gave me some string, what the hell? So this makes things quite robust. So now we can run this thing again, and I'll run it without the level, and it will say your path is dot revolt. There is no level. And if we say source, then we get a path called source, but we can also pass a level and say your path is source and the level is 10. That's great. That's really, really good. We can already start working with some of these things. So let's use these two variables, level and path, and let's change how oak is working. Let's use this variable to affect the behavior of our program. So instead of passing in this revolve function, right, which we don't no longer have, we're gonna pass in a function that executes the logic of oak. We're gonna pass it oak.run. And now this will be the oak.d, or normally I just call it command. And we don't really want to define the name of the CLI here to be revolt. We want it to be something else. And of course, this is failing right now. Yes, this is failing, and it's essentially failing because our function, right, if we open the oak module, takes no parameters. And if you're surprised, this is all the code that we used in the last, this is the synchronous version in the last stream to build oak. It's a very straightforward program. that just takes the current working directory and finds all the files in there and then prints all of them. So that means we need to change this to take the parameters that we expect. And they're going to be in the same order as we apply them here, right? Level and path. So if we get a level and we get a path, now we have a different error, which is, hey, you're getting an error, a level and a path, which are something we don't really know from this module, because the connection is made from the main to the awk module and not the other way around, as far as I understand. We can ignore the level, but we should probably start using the path. So instead of getting the current working directory, right, let's just say, okay, I'm going to get a path in here, and I'm just going to pass it in. And while we're at it, we can just remove, actually, let's use this current working directory instead of the string by default here. It will be easier to understand, oh, this is the default value. So we can say file, current working directory, awk.file. And now we can save this thing here, and it will execute correctly. So now we get this level and path, and we are passing the path to all the other functions, just like we did before with current working directory. And if you are surprised, when we call main exec, we should get the same behavior, right? But now if we call source, then boom, this actually lists everything in source. Sorry that took a while. Type safety sometimes, but it's totally worth it at the end. And we get a question here. It says, could we make it work with bigger numbers, or would that be unnecessary? Well, normally you would, for this use case, it would be unnecessary because you don't really want, if you're gonna be traversing over like one, so that's 1,000, a million, a billion, and a trillion files, then if you have more than a trillion files in your computer and you want to traverse only over the first trillion, then you can do it. 10 trillion, it works, and then 100 trillion, it works, and then 1 quadrillion, it still works. I don't know if it's practical. I think it will be unnecessary. Anyways, this is awesome. We have something that's working now. We have covered one of our use cases already. We can go into any folder that we want. We can go into var. Oh, okay, there's a lot of permission denied stuff there. But we can go into build if we want, and we list only stuff in build. Cool, I'm actually excited about this now. Like, it didn't take that much code, if you look at this, to do the complete parsing exactly how we needed it to be, and so on and so forth, and to execute the CLI. There's a few concepts that we needed to learn on the way, like what the hell are these inline operators, but they're essentially sugar for calling some functions that make this code more terse. Of course, if you're familiar with the framework, then the next time you pick it up on any other command line tool, you'll be instantly familiar with this, and you'll know, oh, this is exactly how it's used, what it's doing. So all command line tools that I've seen around that are built with Cmdliner use the same pattern, which makes it very straightforward to pick up someone else's work and just learn how it works or modify it and whatnot. It's great. It really is great. So there's something that I don't quite like about just having these variables here around, and it's essentially that the more we have, the more they clutter the scope. So something that I've grown used to do is just put them together in an args package. So now here I can just say like args.level and args.path. And everything still works, but now we have this small module. Sorry, I think I said package, I meant module. We have the small module that packs our arguments together. And of course, if you have many arguments, then maybe it makes sense for you to pack them even more deeply into different modules or have a different structure altogether. This is completely up to you. This don't have to be defined here. I think one example of this, if I could show quickly, is on a tool that I've been working on. Cactus bean main. I actually have one module that has shared stuff, and then I have one module that has one of the commands, and in there, as you can see, there's a lot of stuff going on. But from the outside, when you want to use it, right, you just reference build.command, and that's everything that you need. There is nothing inside of the current scope that makes it a little makes it harder to read what's going on. Okay, so that's a CLI bit. It's running, it's doing the thing. We have modified the behavior by passing in the path. If you go into a plan, we essentially have a path from where to start. And I will replace this with an emoji of check. Awesome. We also have the level, but we're not really using it. So maybe we should try and use that. But just, I would actually like first to take care of the help and the verbosity, so we can tell what the tool is doing with more granularity, which will help us when we develop it. So I will have a look at that. And in a second, because I would like to do a small 1-2 minute break to drink some water and relax my throat. In the meantime, if you wanna check out the other events that we have, just go to the events tab over here. I'll be posting more soon, but you can click on past events and see some of the other streams that we had in the past. Same if you go into videos, you can take a look at some of the videos that have descriptions and whatnot. Leave a follow if you are on the channel and you like it. I'm trying to build a small follow base to make content that is relevant for the community. So following and letting me know what you find interesting is very important for us to build, to have material that works for onboarding more people into Reason and whatnot. Have a look at the repo and so on. Okay, I'll be right back. All right, let's get back into it. There we go. Here are the knuckles. Cool. All right, so we would like to have a help flag to see essentially how to use this tool. So we would like to call it something like this, help. What? We get this automatically? No way, how do we do this? All right, so that's my fake surprise. By defining all of these arguments that we have here, right, in the arguments module, and passing them all into the term that we're building, we automatically let Cmdliner know what the options that we want are, right? And what the documentation for them will be. So it can definitely put this thing together. It not only can say, Okay, the argument should be some options, which are many, right? And then a path, and the path when absent is a dot, and it's a path from where to start listing files. And the level with the two aliases, and now we can see this level name appearing again here on the right, and how many levels deep to go. But also we can use this flag help format to be able to print this text, this help in different formats, which might not seem very straightforward, but some people rather have plain text, right? And this is very useful as well, because sometimes listing everything inside of this view, the manual of Oak in this case, it's a little bit daunting. You enter there and you go like, oh hell, what the hell is going on? This is not what I wanted. I don't know how to exit it, even if it says end. I press enter, space, nothing happens. Escape doesn't do anything. You need to know that it's Q and so on. So plain gives you the regular help that you will normally just not need to get out of. And I haven't looked into how to hide this thing and make it default be plain in case that's the only way you want to use it. But you can do other things. You can do help, I think, a graph if you want to pipe it into something else. Or what is it? The format is pager or plain whenever the term ever is dumb or undefined. And I don't know what pager is. I forget. Oh, okay. So this is pager. Cool. Today I learned. Thanks for that reasonable coding. You have taught me well. Or I mean, you have taught me something, at least. All right, so we have these two variables in here, and we can 100% check the help from here with everything that we need. But it would be nice to add some of the other ones, right? Like verbose, and actually use them, which will let us know what's going on, and we can debug our code much more nicely and run it both in air quotes production mode or air quotes development mode, right? So let's do that. Let's add debug flag. So we'll just duplicate this thing because we already have it, right? And we'll say debug. And documentation is should it run in debug mode or not? And the value should be an option. No, the value should be, yeah, it should be an option. So we should have some label. But do we want people to say yes or no, or do we want to just use the flag so that when you call debug, it just knows that it has to debug something, and if you don't, then it knows that it shouldn't. Let's have a look and see if it has support for flags of any sort. I'm gonna just search for flag in this document to see if there's anything in here. Aha, so we do have an optional argument without a value is either a flag or an optional argument with an optional value. And it looks like we have something called a flag that we can use for this thing. It also looks like there's some nice things that we can pass in, like once you define flags, they can be grouped together. If you've ever, actually, I need to do this, xkcd and then tar command. This is just a hilarious piece of internet pop culture. Randall Monroe makes really nice comics, and it says, "Rob, you use Unix, come quick!" And the bomb essentially prompts you that to disarm it, you need to insert the valid tar command, and then says you have 10 seconds, and then they ask Rob, and he goes, "I'm so sorry." And the reality is that tar does this thing where it lets you change the flags in this way, and Z will mean one thing, and X will mean another thing, and V will mean another thing, and F will mean another thing, and you can do it in different ways, right? And they're all completely valid, I believe, unless the ones that cancel each other. So not everybody knows exactly how to use it. Of the top of your head, most people just know that okay, XV will do XVF will do something, right? Or like CF does something, and yeah, we get that ability to confuse our users for free, apparently, which is good. I mean, not really, but it's good that they can do that if they know how to do it. All right, so let's see how we can use the flag. So I'm gonna optional arguments. I'm gonna just click on this flag and see where it takes us. Cool. So apparently flag just takes some info, right? And it returns a boolean. All right, so the flag works much more simply than other combinators. So if you say flag I, it's a bool argument defined by an optional flag that may appear at most once on the command line under one of the names specified by I. Okay, so I, because it's an info, it will have a bunch of names. Similarly to how we define L and level, we can just say if we have D and debug, then this thing could be a flag. And I am curious as to whether we need a .v because we have no value. So it looks like if we do something like that, right, and then we pass this thing here, and I'm going to put it at the end, and args.debug. Perfect. So our command fails because now we need the debug flag, and if we add a debug flag here but ignore it, then it should compile. And it didn't compile. Oi, oi, oi. What did we miss? Line 26. Oh, right. My bad. I used the wrong symbol. This should be a dollar sign. Uh-huh. On line 26, we still have an error that this thing here is an argument of type Boolean. But we were expecting something. Oh, we were expecting a term. All right, all right, all right. So I think that we still need to have the value because the value, if you remember, takes an argument and turns it into a term. So if we keep the value there, then this runs, and then we can just run the help again. And now we have this debug thing. Great. That's pretty straightforward. So now we can just use this debug flag and say everywhere, right? If the debug flag is set on, then print everything that you're doing, for example. Now there's a lot of ways of dealing with this debug mode, and one of them will be to essentially pass this debug flag to each one of our commands, right? And I'm making a name parameter so it's a little bit easier to figure out. And by default, it should be false. And same here. But as you can tell, doing this, it's kind of dirty. I mean, no, wait. I'll rephrase. It's not dirty. It's clean, air quotes, but it's super frustrating because if you forget to pass on this debug flag to some internal function, or in the recursion, for example, here, and it will be very easy to do. In fact, I just forgot to do it. Then all of a sudden your debug mode will not work. And as it turns out, we normally want to think of whether you're running in debug or in production as something that is spread automatically through everything in our application. So because we don't want to deal with that, we can delegate it to something else that knows how to do this. And the reality is that one easy way of doing it, it's a hacky way, is to keep a global mutable reference to a boolean. But this feels super dirty. At least doing it so manually and so exposed like this, and not encapsulated in a nice interface for us, feels very dirty. So what we can do is rely on on a nice encapsulation of that pattern. Why? Because if we take this debug, right, and we set it to reference false here, and somewhere in here we do debug should be reference should be just true, then we activate debug for everyone else even though they didn't mean to use it. And sure, we're all responsible adults, or we're responsible developers and engineers, but come on, if you can do something, that means that somebody will. Doesn't mean that they will ill intentionally do it. It just might be a mistake. We're all human. So the reasonable thing to do will be to prevent people to do the wrong thing. As Don Norman likes to say, if the user used the program wrong or the device wrong or the product wrong, it's a design flaw. It's not the user's fault. If you burn your hand because the stove is just too easy, is too exposed for you to burn your hand on or for you to touch it, is it a problem with you going all in at it, or is it a problem of the stove letting you do that? I think it's a stove. We should strive to make stoves that don't let people hurt themselves, regardless of how they use them. There's a lot of ways of phrasing that. That's the most politically correct one that I could muster. Okay, so there is a library that is also built by Daniel Bünzli that is called, and you can see here the plethora of libraries that is built for all of the different essentially domains that will help us here. And this is an infrastructure library, and it's called logs. It's essentially a logging infrastructure. And logs, which is a great name for a logging library, lets us define with some reporters different sources and lets us do logging in a very scalable way. This is not just I'm going to print f here something and I'm going to print f some other here somewhere else, which is valid, perfectly valid to do. This is a library that's built to report in really big applications that are synchronous or asynchronous, that will work in the browser and also natively, and will work with all sorts of formatters. So it can write to terminals, but it can also write to files that will be forwarded to log aggregation services and lots of things. And it's also built so that logging and all the computation you need to do for logging at a specific level, like verbose or normal or debug or error or warning, only happens at those levels, right? So if you have some really computationally expensive piece of work to do to be able to log that you're debugging a complete list of elements, for example, taking a list and turning it into a list, a string representation of the list, which means you need to take each element of the list and turn them into a string as well, which in languages like JavaScript is super cheap, or cheaper, or at least very cheap for the developer to write it down. In other languages, it might be really expensive. Here, this library lets you say, this is what you need to do to log it. Only do it when and if you need to log this, which keeps your application performant. So this is really the quality of most of the software he does. It's impressive. Let's take a look at the docs and see how we can use it. So there's a few modules here, and there's one even that supports logs for Cmdliner. So let's quickly take a look at logs, but also open Cmdliner logs and see what happens in there. So logs provides a basic logging infrastructure. Bullshit, is not basic. It's actually pretty interesting. And it says logging is performed on sources where reporting level can be set independently. In our case, we don't really have more than one source, right? It's just oak. But if you had an application that uses a lot of libraries, then each library could be its own source. And then you could say, let's debug this particular sub-library in the context of this whole application. And it says that the log message report is decoupled from logging and handled by a reporter. So it doesn't really know how to write things down. You can say, use this, write to disk or write to a file, which we already said before. And that's pretty cool too. We can start with the basics and see a few usage conventions. So let's take a look at the basics. In the basics, it says to minimize the overhead whenever a log message is not reported, message formatting only occurs on the actual message report via the message formatting function, which is what we were talking about before. This leads to the following logging structure. So you call logs error, but you pass in a function that will do the work, and it will return the work into some formatter. And the pattern is quite simple. It is as if you were formatting with a printf-like function, except you get this function in the m argument of the function you give to the login function. Oof, that's a mouthful. So m will be something like printf that you would receive as the first argument of the function that you are giving to our log. So when you want to log something, you give it a function, right? And that function will receive the actual login function that you can use. This means that none of this will be executed unless you actually require it. And because you're using this function that is injected, then you can swap this m with some configuration somewhere to print to a console, but also to print to a file or wherever you want it. And again, it's fairly flexible. Cool. Arguments. There's some other examples that I haven't looked into. There's a reporter setup, how to set up the reporters. There's a CLI module, has a full setup example. That includes command line options to control color and log reporting level. All right, let's take a look at that. If we're in the log CLI module, we can just go into the example, and it says the following example shows how to set up the logs and format library so that logging is performed on standard outputs with ANSI coloring if these are TTYs. Hell yes. This FMT is also a library that Daniel Bünzli has written. He's written a lot of infrastructure, which is very, very interesting. Okay, so first things first, let's make sure that we have logs and we have FMT available in our package. So if we open our Dune files, you'll see the binary one here, and we want to use logs and we want to use FMT. Why we want to use FMT is that we will need it to tell logs how to report things, how to print things in the terminal. And because we want to be able to log things in our application, then our other Dune file, the one in Oak, will also need to have, oh, look at that, logs, already have it, and FMT. And well, we are not actually using boss, so it should be able to get dropped. Yes. Sorry, this is from where I was sketching the application before, like before the last stream. So it stayed. Anyways, this thing is building. We can close the build files now, the Dune files. This is partially done. Now we can take a look at how to actually do the setup. Just to be sure, let's see if we have a logs module, and we have logs, log CLI, FMT. We even have logs browser. Nice. And oh my god, hello horrible world. Jesus, dude. Cheer up a little. The command line interface provides options to control the use of colors and the log reporting level. That sounds cool. It appears to be that we can do the setup of the log by getting the renderer and the level like this. And in our command line interface, we can define this term that we can pass into a function. And it appears that the result of this will be unit. Yes, unit. And that's what gets put in here. Okay, I need 1 second to switch my headphones. They're running out of battery. Hopefully you still listen to me. If the sound goes away, or if anything like that happens, just let me know. By the way, if you'd like to help me out, get some reach, I just tweeted that we are live. So if you go to, I'll send the link to the tweet, and you want to retweet, that would be amazing. Oh, sorry, that's a wrong username. Oh, I should have gotten my username faster on Twitter, but I didn't. How can I link this thing? There you go. I think this works. Cool. It's like there. Hopefully some of your friends will like it, and we can start building a small, tight and nice community around this. Oh, I love that the logo changed from one to the other, but this didn't actually update. Right. Cool. So closing that. Sorry. Log CLI. Hello seems to be the application, which in our case will be oak.run that takes some parameters. And the function setup log is something that we will need to replicate. All right, so let's start by building the term, and then we'll fill in the gaps. So we will have a term, and we can call this verbosity. And this term will, I think, yeah, I'm confused. Setup log is defined here. And the style renderer is something that we, oh, okay. I bet this thing and this thing define its own terms internally. We can take a look at that and see exactly what they are. So if we do logs and CLI, CLI dot, what is the name? Level. This should be a term. And yeah, if you evaluate it like that, then you indeed get a term out of that. So we want to do a value, an argument. No, we don't. We want to do a term. Huh. Okay. I am a little confused, but we have const, and we will have this setup logging or setup verbosity, so that we set the right verbosity level in our application. And then we just need to apply this with these two arguments. The first one being the renderer, and the second one being the level. So we can start with the level, and we can see where that takes us. If we save that, it's going to tell us that there is something called setup verbosity that's undefined. So we can define here setup verbosity. And this thing seems to be a function that will take a level, and we can use the level to set the level in there, and we can use a reporter to set, we can set the reporter with this. So this will take a level, and we can essentially do logs, and there should be a bunch of set functions here, like set level. That seems to take a level. And we also have the set reporter here. And for the reporter, we seem to just use the default reporter that comes with the submodule format. So we can do that as well. We can do logs, fmt dot reporter. And if I'm not mistaken, the signature of this will be a lot of optional arguments and then a unit. So we can just call this with a unit, and then this should just set the report for us. Great. What's going on? Const, and of course, this should be a $sign. Cool. So now Dune is complaining, saying, I know that you want to build this thing, but I can't find those libraries. And I think the problem is that we're trying to use logs underscore format and logs underscore CLI, but those are not really part of the logs package. Normally you do logs and you convert the underscores into dots when you define your packages. So if we do format like that, then now it should be picked up automatically, and it should say, hey, things are good, success. Yes, great. Awesome. Awesome. All right, so now we have the log set up, but we aren't quite yet using this verbosity anywhere. If you take a look here, you'll see that we're not using it anywhere, and we kind of want to pass it on to something. So let's take a look at how we do that. Because I see that here we have a term, right? And we're essentially applying this term into another term. And I am not sure how that composes. I think that the output of this thing will be the input of this thing, right? But I would like to run these two things, one and then the other. So I wonder if by applying this thing, set up verbosity, then I will automatically, no, okay, that didn't work. Then, and why is that? Oh, sorry. Verbosity is the name of the argument, of the term. If we apply this thing, what is the verbosity? Returns a unit, and verbosity is a t of a unit as well. Interesting. How can we combine multiple handlers? I think that this means that the first thing that we'll evaluate will be the CLI level, and then we'll try to set up the verbosity, and then whatever this returns, right, will be evaluated with the rest of the things. So I'm wondering how I did it before. So to do that, I'm just gonna take a quick look into a different project where I've done this already. And we're gonna take a look at main. And in main, we have a function called setup logger, right? That is very similar to what we're doing. So if we look at the flags variable, we'll see that, okay. We are essentially putting the flags between the command and all the options. Just an interesting take. All right, let's do that. Let's see if it works. And if it does work, then we'll go back and see why it works. Verbosity. And we build it, and yes, it makes sense. It's rx.verbosity. And it's still failing because verbosity is a unit, and then level is an option int, and path is a string, and then bool. Andogrun is a function that takes a unit, a string, and a string. All right, so now let's take a look at the at Cmdliner and see if it has any docs that we can use. Oops, that's not what I meant. Cmdliner, docs, Cmdliner, that we can use to essentially apply this verbosity, but not sort of ignore the argument. Examples, remove command, it has an example here with flags and values. Prompt recursive files. Okay, I'm gonna go back and I'm gonna take a look at term and see if term has something that we could use. Alternatively, something we could do is do give this function, right, run, the extra parameter that we're being asked to give it, right? So it should take a unit and a string, and if we go in here, this takes two weird things. What I mean when I said two weird things is that run takes some A, whatever that is, a string, and some B, whatever that is, and then it will return a list of units, which maybe means we need to iterate over here. Same error. Okay, so this didn't change anything. Let's go to line 35, and on character 38, character 38, we get this weird thing, this error. It says this expression has type int of option, right? But an expression was expected of type t string. And of course, it makes sense that int of option is not compatible with string. I'm going to go back to see how the hell did I do this before. Because this is a div unit and this is a div string, and then okay, all right. So I think that actually I need to specify the argument for this, even though I will ignore it, which is a little less nice than I expected it to, like flags. And yeah, that worked. Okay, so now we run the help again. Then as you can see, we get a quiet and a verbose and a verbosity with a level. And the level can be quiet, error, warning, info, or debug. Nice. Okay. So if we have a debug, then we don't actually need our own debug, which was nice to have, right? But unless we need a different flag, and we do, we need use git ignore. So we can just rename this to use git ignore. And we'll only give it a long name. We're not going to give it a short name for now. Use git ignore. Oops. What? Array? No. I want to args. Use git ignore. Okay. We also get this nice list now, and you can see all of their arguments are there. So if we do the help, we get the verbosity levels, we get the use git ignore flag, we get the level of how deeper to go, we get the path. We're all of a sudden, building and using a very, very flexible tool that has a lot of parameters and arguments that you can configure. So now we need to actually use this login library, right? We have done the setup that gives us this levels reported somewhere, but we're not really, this levels configured somewhere, but we're not really using it. So we can start using it to take a look at what it will be like and distinguish between different log levels and so on. And, oops, sorry. To use it, we do logs from anywhere in the code, and we can just do, we have a few functions here, quite a few. There is one associated to each one of the levels, and as you can see, we have an application level, a debug level, an error level, an info level, and a warning. So now we want to do an info, or let's say a debug. And for debug purposes, we will say that the path that we're using, and this should rename to use git ignore. The path we're using should be a string, right? And it will be the variable path. And we can start with this. So if we run this with source, we get just that. But if we add debug to it, verbosity equals debug, then we get this nice log line that has the name of the executable, and then it has debug, and then the line that we want. This is mostly useful when you have multiple libraries and you want to debug or log things for each library separately. But right now it doesn't hurt too much to have it. So when we're on debug mode, we probably want to log everything that's passed in as a parameter. So let's do that here and say the path will be this one, use git ignore, and this will be a boolean that we log, so we can log use git ignore, and we're gonna log the level as well. Level, max level, and this should be because level is an optional, I believe. We don't know. Let me just remove that and save, so we compile and we get type information. Oops, sorry. There we go. Huh. It's a string. Why is this a string? Okay, so there's something a little odd going on here in that when we try to log more than one thing at a time in different calls to M, it forgets what's what. So let's do something else. We're gonna do a multi-line string, right? And we'll begin with use git ignore, and then the next thing we're gonna do is to put the path there, and then what is it? It's a pipe j brace, and then we're gonna say the next thing that we're gonna log will be the level, which will be a number. Actually, let's use a string here, and you'll see why in a second. And yeah, this should be the three variables, the three configuration options that we're giving it, right? I think that should be good. So now we need to give it the variables to put in those places. And the first one should be a Boolean, and the second one should be a Boolean, and the third one should be a string. So we'll do level. I'm going to make a variable here called level that will essentially check whether the level exists. And if the level exists, then it will use it. Otherwise, it will say no limit. Some L, and then we can do L, and then string of int. Cool. And if this builds, it built and it's successful. So now if we, oops, sorry. If we run the command again, it doesn't print anything, but if we have verbose debug, then it will say using git ignore, false, path, this is the path, and then this is the other thing. I don't quite like this too much because we're getting all of this logged inside of the same line, and it doesn't look very readable. But we can also just, yeah, we can use that as well. So if we pass in use git ignore, and then we get git ignore is true, and if we pass a limit of 10, then it says the level is 10. So we have all of the things we need to inspect the variables. Now, this will be a debug call, right? And info call that we do could be listing files from path, starting from path, some path, and until level. Okay, just listing files starting from path, and then like that. So if we run this thing again, oops, I'm missing a path here. If we build and run it, then it doesn't say anything, but if we give it one verbose, then it says listing files starting from path, something. If we wanted to get rid of this thing, then we can just use the app level. But of course, we don't want this tool to actually put more stuff in there. Why? Because if you use it as it is right now, then you can pipe it into FCF, and then you have everything there, and you can just search for files with fast searching and whatnot. It's a very Unix friendly tool. Okay. And then as an info, we can say done as well. But most interesting is that now that we have this, we can just say let files, and we can save all of the files, right, before we print them. And I'm changing map to ether because we don't really need to use the output of the print. And now we can say listed so many files listed so many files. And then in here, we can just say files and get the length of this list. So if this compiles and it succeeds, great. And we can run this in slightly verbose, and it will say listed 15 files. Now you might be wondering, why on earth is this line appearing after all of the files? And that is because this printf over here is appending things to the buffer, but it isn't actually flushing it. And we can flush it automatically by adding a percentage bank. So if we run this again, then you'll see that we say listing all the files, it lists the files, and then we see the other thing. Now, one small trick or one nice thing to do here is that because we can now tell how many files we're printing, right? And we have a nice way of showing and hiding logs. We can also say how long it took to print these files, right? Which is an interesting metric to have. So let's begin by saying like began at, and we're gonna use the Unix module to capture the time of day. And we're gonna say, if you're gonna be logging the info, right, then we might as well log how long it took. So the delta will be another call to get time of day minus began at. So the time we began at is the thing that we subtract from the time that we have right now. And get time of day is a float. So we need to use the float subtraction operation, which is dash dot, which means this is the float as well. And now we can say listed some files, n files in, and we can say I want to float, but I want to float with let's say 3 levels, 3 decimal points. And now we can pass in the delta here. And if we save, this auto formatted. Cool. Now it's complaining that we don't know what the Dune, the Unix module is. Dune is complaining. So if we open the Dune file in Oak, then we can just throw Unix in here. And it builds, and after it builds, we can run it again, and he will say, aha, it took this many milliseconds, very, very few. So if you want to just add 5 digits of precision, then you'll see that this is fairly fast. So this is milliseconds, and then this is nanoseconds, I think. Yeah, and this is microseconds. Will this be 44 microseconds? Someone out there in the audience, please let me know. I think I'm being very unreasonable right now with my units. Units, microsecond. Oops, units, damn it, units, microseconds. So it's if I make this big, it's 1, 2, 3, 4, 5, 1. That will be microseconds, 1 microsecond, right? So if you go here, we have 1, 2, 3, 4, 5. Okay, so this is not microseconds, it's the next one. So what's the next one? Elm? No. Hey Adri, how's it going? We're doing recent ML here, and we're compiling everything natively. So as you can see, it's just insanely fast. This is the amount of seconds it took to list some things. And we're using Dune for building. Yeah, do you normally do Elm? Where is it? Second? No. I want to see the system of units. Orders, and that's one. Nice. Oh my god, so much stuff. So where's the second? So millisecond, and then micro, and then nano. Okay, micro and then nano. So there's quite a jump there. So I guess the jump is not as cool. MS. All right. So that's 3 milliseconds. 0.3 milliseconds. Anyways, it's fast. You get the idea. And because we're adding debugging still, and we probably want to know whenever we enter a new folder, so we can do this here. We can say, all right, logs, debug, and then, we want to say entering folder or entering path, entering directory. I think that's the proper naming of this. And then we can put the during here, right? And then we can say how many files we found, files and subdirectories. So it's files, and then we can just say list length, and then we can say theirs, and then we can say list length there. Cool. So if we run this with verbosity debug, then it will say listing files starting from path source, entering directory source, found 0 files and 2 subdirectories, entering directory source oak, found 5 files and 0 subdirectories, entering directory source bin, found 5 files and 0 subdirectories. And these SWP files are essentially some swap files from Vim, so don't worry about them. That's more clean. Now, something that's a little bit bugging me right now is the fact that we're building the list of all files, and then we're printing it at once instead of printing things as we go and not needing to keep track of what's where. But that's an optimization or a change in the program that we don't need to do right now. As you can see, what we do have is verbosity levels in different levels, so we can just use verbosity info, and we'll see only the info, right? Or debug, and we'll see everything included to debug. And I think debug is the deepest level. All right, so wow, this all of a sudden is a much more usable tool than it was before. It used to make so many assumptions, and now it just doesn't. I'm just gonna remove that there so we don't get this annoying extra line here. Let's see our plan. We have verbosity and we have debug mode. We don't really have a debug mode as in a flag that's called debug. We can add that in because typing the verbosity debug is really annoying. So we can show how to do some other usage of flags. We definitely have a verbosity flag. And I think we also have a color flag somewhere. That if we do color, let's see, help. Oh, sorry, we didn't quite add that yet. So let's add the color flag, and then we can take a look at adding the verbosity debug as just debug, or D, which is more straightforward for development purposes. So if we go back into the documentation that we had open somewhere here, where is it? Log CLI. We will see that we have the style renderer from FMT, and we need to set up some STD options, standard options. All right, so then let's pass this thing in here and let's call that thing in there. So format TTY setup STD options. And you'll notice that I type everything because I really want my fingers to remember what to type. So we'll have something called style renderer, right? And then the other thing that it gets passed is just a unit, okay? Which means if we call it like this, it will return us the rest of the function. So we need to call it like this. And of course, it doesn't know about style renderer, which is we need to pass it in as a variable. So if we pass it the style renderer, then it will complain somewhere else that we're not giving it to it. And that makes sense because we're missing it here. When we call set the verbosity through the framework, we are not giving it what it expects. So I'm expecting that FMT CLI will have a style renderer. Okay, so if we save that, then we get that thing over there. Cool. And I think I messed something up. Let's go back to the example and see what's going on. We are passing in the style renderer that comes from here, right? FMT CLI, and then we just give it into setup, std outputs, style renderer. I think we're doing the right thing. We're calling style renderer, and then on line 12, we're calling the wrong thing. Why? How come? I ask, how come? So if we call this with a unit, we get a T option of style format renderer, and in here, the style renderer is right. Okay, so this thing, I believe, is expecting, could it be that this is wrong? Maybe it is wrong. This function, setup std outputs, is expecting us to give it, no, come on, you should be okay. An optional style renderer, right? Which means this function over here should be really getting an optional style renderer. Why isn't it? Option of format style renderer, and then you can figure out the rest of the types. So that's an option there, and this is an option here. But this thing here, style renderer, it gives me an optional edge. What the hell? I do not understand. Huh. By the way, if you're curious what this is, you can specify the signature of your functions after a colon on top of them, right? And then I think this is much nicer than putting them in line here, like option, FMT, because you can look at the type signature of the whole function at once. And these little underscores are essentially telling the type, the type engine to just figure it out by itself. I don't know what this is. I don't know what this is. I also don't care. But I know that this thing is this thing. You don't have to add these things. The inference will add them for you essentially. But I was just trying to check if essentially this function got type checked first, and then it came up with some type, then was not available somewhere down here. But I'm starting to think that maybe it's just a dependency problem. Because we are using FMT underscore TTY and FMT underscore CLI, maybe we should include those dependencies too. So if I'm going to go into Beam Dune, then maybe I should do FMT TTY and FMT CLI. And if I save, I don't know if that worked. Yeah, that didn't do anything. Interesting. FMT CLI. Any ideas? Starting to think there's something I'm doing that's wrong. Logs reporter, and then we do the style renderer there. Set up log, same thing. It's probably a very silly mistake that we're making here. The ordering is the same as well. This function, I don't understand why it's not inferring the right type. So format, setup, std out. What else do we have here? Setup. Okay. And the setup just is pretty much the same in that it takes the style renderer, right? But it will take a std out channel, and std out is already defined, so it will be like calling this really. And that didn't work. Aha, so this gives us a formatter back. What the hell does this give? This gives us a unit back. Varför? Why? Okay, let's see if I just call the name of this something else. No, sometimes the punning, I have the impression, I don't have any evidence that sometimes the punning does weird things, but it should just be syntax. So calling this thing here with no environment should give me, okay, so this function, right, has a signature that's here. It takes an optional environment, optional documentation, and if you apply it with a unit, it will return you an optional term of a style renderer. Good. I'm gonna do something that I normally don't do, but I'm gonna clean the project and go watch. No, okay, the error is the same. Dune is really solid when it comes to these things, but you never know. Computers sometimes are insane. Okay. New things down. I am just, why isn't this an option? This does not make any sense. Style renderer. And now line 5. Alright, so I'm gonna try to call it outside and just go fam tty, set up std options, and I'm gonna call it with none, with the style renderer equals none, right? And I'm gonna see what the type of this thing is. So if I go here, then it's an optional style renderer, which means that if I call it with that, this seems to work. So style renderer, oops, none here is an option of A, which in turn is a style renderer. So it's an optional style renderer, and that works. I'm a little bit blocked here. I'm not entirely sure what the problem is. I have not used this FMTT2Y before in this same way. I'll have a look at how I used it in other places. Cactus, for example. In Cactus, I just enabled it all the time. Okay, so maybe we can do that. Just as a compromise, we can say that we want to enable the colored output rather than having the flag there. And sure, if we were more free when it comes to time, then maybe we'll be able to work through this. But we're gonna do a cross here. We couldn't quite get this thing up and running. That's all right. Some things don't work the way we expect them to. For example, using emojis in Vim always adds this extra space. And okay, now I start to see why. Now it's telling me that FMTTY is missing, but we knew this in source bin main. tty, and this is going to complain about CLI as well. So if I add those two things, then it goes, and I wonder, now I wonder if I revert these changes, then this thing will work. And it doesn't. Okay, fine, okay, you win. Computer, in this instance of the thing, you win. So now if we call source, oops, no such file or directory. If we call source, it says that. If we add verbosity debug, then you'll see that we have this nice blue and green for debug and so on. And we have some verbosity, and we like to have a debug flag by default. So let's add that. Let's say that the verbosity level will actually be, we set up first by using debug and then the level. So we don't need to put debug anywhere else. And now we get the debug variable in here, right? So essentially debug will be a shortcut. If it should be an optional value. Let's define it over here. Debug shortcut for debugging mode, verbosity, and let's just say will be D and also debug. Cool. So now it says that it has errors. Interesting. Line 3, unused variable. Cool. And this is a function that will take some variable that we don't know the value of. It will be a boolean. So if we do have debug, then we want to set the level to debug. If we don't have debug, then we want to set the level to whatever you're setting it there, right? So set level, and then this should be level should be logs, and then I think debug should be the level. There you go. So let's wait for this thing to build. I think this should need to go this way. It needs an option. Cool. So now we can run source and it's the same, but if we do D, then it's a debug, and it has everything, which is much more convenient. And I would say we've managed to add this verbosity flag. It's not verbose quite, it's verbosity, and debug. We're pretty farther in, pretty far in. I will say something else that we need to do that I found out by accidentally putting a wrong path is handle this error more gracefully. So in our application, we could do this. Somewhere in there, this partition function is going to fail, and we want to essentially make sure that we handle the result, the problem. So we can do this by either returning no files and no directories. But first of all, we wanna make sure that we can log out the error nicely, and maybe ignore the folder altogether. So one way of doing this will be to say switch on this expression, right? And then in there you can either you get there's some files, which you just return as there's some files. So I guess you could say like any value that you get, you just pass in directly. But if you get some exception, and then would be an exception called let's call it E, then we could just call logs.error, and then we can just say something went wrong with path, and then we put the path in there, and then we put the exception as a readable error message. So we put the path in here, which is called dir in this level, and then we have this function from a module called print exception that's called toString. so we can turn any exception into a string. And if we save this thing, then the code formatter does something for us. So after we log this problem, we just return 2 empty lists here. And this is super ugly. So instead of doing this thing, let's return none. And let's say that if we have a problem listing these directories, we will just return none, and otherwise we return some, which means maybe we want to invert the way that this works, right? Instead of taking the value out, we just want to run this thing, and if we do get the values in, then we will run the rest of the code, which is what goes on in here, which will make this look a little different. But you saw how the code went a little bit to the left and a little bit to the right. So if something went wrong, something goes wrong. But if everything's good, then we debug that we found this many files and directories, and we continue evaluating everything else. So now we have a problem here, and it's that this is returning none, when in reality we wanted to return an empty list. Cool. This kind of makes sense. I honestly don't really like this thing. I would very much like to abstract this away. So we're gonna call this let partition. We can actually, I think we could call this read there, and it will take a directory, a path, and then it will evaluate this thing, right? It will do the partitioning for us. So now we can just say directory goes into read there, and now this reads much more nicely, and it still catches the same problem. But one last problem is that right now we don't really know which one is the directories and which one is the files. Anyways, we will run this thing, and with a good path to see that it still works, and with a bad path to see what happens. Okay, that's good. Now we see the error there instead of the whole program blowing up. If we use verbose, then we'll see that it says listing files starting from path, and then it says something wrong, and then it finishes it, which means I think we've handled the verbosity. I have no idea what's going on with this word there, but let's assume that that is the right word. Okay, we're handling the verbosity more nicely. Just making the code a little bit file count. More count. Just bear with me for a second while I rename these things. File count and their count. There you go. Flatter. That's what I meant. Instead of all this nested expressions. Okay, so this looks good enough for me. What do you say? Should we go ahead and try to implement the git ignore? Oh, sorry, Xavier, I forgot to address your comments. The FMT style renderer that we were using before is from here, right? This is returning a Cmdliner term that we'll be able to apply. And I mean, we can go into the FMT module, FMT docs, and he'll be able to see what is that? Not yeah, documentation, docs index. Okay, and we'll be able to see what the product printer is. And somewhere in here, you should have, yeah, it has a type T. There's a formatter. Okay, 1 second. I need to go to the bathroom, but I'll be right back. And when I'm back, I think we should implement the use git ignore instead of the level. If you think that we should do the git ignore or instead of the level, then just leave it in a comment somewhere down there, and we'll address it when I'm back. Now is it working now? Okay, now I get some signal here. I have no idea what's going on. Software. Anyways, let's get back into what we were doing. Hopefully you're still with me. And if you aren't, too bad. Come back soon. All right. So I saw one comment saying that maybe we want to take a look at the git ignore file instead. Great, that works. Hopefully you get a break as well. I know that sometimes, I mean, we've been streaming for what, 2.5 hours directly. That can be quite intense. All right, so let's do some scoping of what we need to do here. If you pass it in and there is no git ignore file, should we fail or should we not fail? Or should we, does this mean that we should just look for it? Do we fail? Okay. And if we find one, we should ignore the .git folder, the .git ignore file, and anything listed in .git ignore. Now we can get very fancy in here, right? With pattern matching and whatnot. So maybe we want to start by saying it would have to be an exact match, right? If it's in the same list, then it is. And then after that, we can make it nicer. What does that sound like? Any yes, any no's? What do you feel like? I think it'd be helpful to get something up and running, to just look for the file, and if we find it, we can just print it or try to read it, right? And then after that, we can decide how to do something else. So I'll start doing that, and you let me know if you rather we did something different. So thankfully, we already know that we should use a git ignore flag or we shouldn't, right? Which means that when we find all the files, we have some options. We can find all of them and then filter out the ones that we don't wanna use. Or we could thread this inside of find all, so we ignore things directly. I would like to begin by saying that first we will read the git ignore file, right? Ignores, and we will have some module called git, right? And then this thing will be like git ignore ignore file, and then we need to give it a path so that it knows where to look for it, right? So let's add this here, and I'm going to add some spacing in the middle so that we know we don't get too confused, right? Sometimes this happens naturally, the spacing in between things, sometimes it doesn't. All right, so let's assume we have a module called git that gives us an ignore path, ignore file. Should we call it ignore file, or should we maybe just say git ignore ignores, ignore list, ignore files, ignore paths. I'm gonna go with ignore paths. I think it looks a little bit better than ignore files, and it's more. I think it makes more sense. You can ignore a folder, right, like a source. But you can also ignore a file, and path works for both, but file doesn't work for source, which is a directory. So we expect this thing here to be a list of strings. All right, so now that we have the interface there and we have the files, maybe we want to feed this thing into find all, right? so that if it finds something in the list, then it just skips it. And we can do the reading of the file in here. We don't really care how Git does the reading. We just care that it gives us the data back. API wise, does this look all right? So this will prevent us from going into directories that we need to skip. I think even better will be to tell final when to ignore, or so if we actually give it a function, a predicate, right? It will give us path back, and then we can say true or false if it needs to ignore it, right? So maybe we can say that oh, I read the word ignore so much that now it looks weird, and I haven't read it that much. It's kind of insane. Where am I? 1, 2, 3. Sorry, I'm on my phone. I'm making sure I have Twitch open still. For a second there, it disappeared. All right, so ignore paths is going to return us an ignore file. So maybe we just should just ignore file, and then we can pass this ignore file into a function that if you give it the ignore file, then it will tell you if this file should be ignored or not. So should ignore. Right. Does that make some sense API wise? Like, yeah, this looks like an API that is easy to understand. We get the ignore file, and then we build a fill function that we use to ignore something. And then we pass this function to the find all, and find all will essentially use this function first, and if it should ignore something, then it will just ignore it and return nothing. But if it should not, right, then it will continue and do what it needs to do. So good so far. I think it makes, at least to me, it makes some sense. So I'm gonna just call it here, git should ignore, and we're gonna pap the ignore file here. Which of course we can do much more directly by just piping the path into the ignore file folder, and then just piping this thing into this thing over here. And this should be ignore. So now we can write this thing over here as this. So, cool. All right. So now naturally we need to make some module git. So let's go up there and we can add it, but we can also do it in a new file. And I think a new file would be better because we start to have some logic in here, right? So let's do something. Let's create a new file in source and oak, and then we'll do git and re, right? And then we also will create a new file for source oak, and then file re. And then we can first move all this stuff from file here, right, into that module. And because we are inside the module file, we don't need the module definition around it. And if we save, now this is much more manageable, right? It's just 31 lines, and now in the module git we can define some ignore file. This thing will take a path and should return an optional file, so either it's there or it isn't there, right? And that's a good idea. So essentially, ignore file should be this thing, and then the ignore function will switch on the ignore file, and if there is some, right, then we'll get a file here, and we'll just pipe that file into the should ignore function. But if there isn't, then our function will, I think we have an identity function somewhere. Identity, okay, well, essentially will just be a function that always returns true. Yeah, what the hell am I talking about? We don't need the identity function. Yeah, so this means if we do have an ignore file, then we'll use the should ignore from Git. Otherwise, we'll just say true to everything. So we can ignore the file, we'll just continue going through everything. Hopefully this still makes some sense. Now we can just go into ignore files. We need to define this function. And this function will try to read a file. So I think we have right there. All right, we can use Unix exists, I think. Nope. Maybe file name. Nope, I don't see any exists here. Maybe we can use this. And this has a bunch of crap, so let's just do E. Maybe file, this directory. Okay, now we don't have any higher level utilities, so we can use unix.stat. But if we're gonna use stat to make sure that the file exists, we might as well just make an exists function here that takes a path. And for those familiar with Unix, for those not familiar with Unix, stat is a system call function or a command that you can use to get information about a file. If we go into the plan, for example, it will tell us this thing is a file, and this is the name, it's a regular file, and this is some more info about it. If you use it in a folder, for example, like source, it will tell you that it's a folder. And if you use it in something that doesn't exist, it will know that it doesn't exist, and it'll be able to tell you that it doesn't exist. And so we can do unix.stat. But I'm still surprised that there's nothing to tell that exists. Is file. Anyways, stat. If we put this into stat, then we'll be able to get some result out of it. And the result is some data structure. And what we want to do is know that if there is an exception, that means the file doesn't exist, and we return false. But if we get any data out, this should be okay. And it's very possible that I'm wrong with this. So if you know better than I do, please let me know. What we want to do here is append to this path git ignore file name, right? So then we get the path to the git ignore file inside of the path that you're looking for. And then we want to take a look and say file.exists. And I need to save this thing, and exists there. Cool. Interesting. Apparently, file name.append doesn't exist. Is it concat? Yes. Sorry about that. So okay. What we want to do here is ask if this thing is true, then we'll return some, and we need to read the file, right? Contents. If it doesn't exist, then we'll return none, so we know that it's empty. So to read, we're gonna use okay. So right now we've been using this small module that defines some utility functions that we need, because that was kind of the core, the gist of Oak, right? That we will write the functionality of this library and it will do debugging and so on. But for some things like reading a whole file, we can implement our own solution for it, and that's definitely fine. Git ignore. Okay, let's say full path, and then this would be this path, and then we can just do a switch full path exists. Sorry about that. I just wanted to put the full path in a variable so we can use it here. What is wrong? What am I missing? Saved. Line 6 has an error. I don't see the error. And of course, this is an if, not a switch. My bad. Okay. Yeah, so we can very quickly implement the read file, or we can use a library for it. Right now, I'm just going to implement it. It's just it doesn't take too long. You just need to know that there are libraries that do this for you as well. I just don't want to introduce yet another library and have to go through how they do things internally. But if you feel right now that you rather know about the library, just let me know, and we'll take a minute to go through it. We won't make all of the changes, but we will use it for this thing. Chat, open in, then path, then we consume, and we accumulator. Switch, read lines, and chat. So essentially, we will try to read lines, and as long as we can read lines, we will accumulate them in an accumulator. And if we get an end of file exception, then we'll just return the accumulator reversed. Why reversed? Because like we are reading the lines in one way, but we're accumulating them in the other. So we'll consume act. This is contents, and then we can close in channel, and then we can return the contents. Right. So this thing over here that I kind of know by heart by now is that read line chan. Oh my god. Since I've written so much, but it always has a problem. Why you problem me? Why? Right. Okay. So we're essentially expecting something that has. We have no idea what to return, what type. So this should be its list of strings, which is different files that we have. So in line 8 of a file, we will try to read line with this, and we apply it to a channel, and we get a string back, which will be the line there. But when we get an exception out of it, then things go bad. But line 8, why is line 8 so annoyed? Accumulator return, and this is doing that. Huh, I can't believe I just bragged about knowing this from by heart, and now it doesn't work. I feel like a moron. Sorry about that, people. I guess we all seen from, what do you call this? Arrogance, maybe? So line 22, 18, character 22, we have channel. And the channel is an in channel. And a read line takes what? Read lines? Yes. Oh my god, what am I doing? I had to read line. Huh. This would be so easy if we were using boss. Okay. You know what? Let's do the right thing. Let's actually learn to use a library that does this for us in a much better way. Okay, so I'm going to introduce you to the BOS library. And it should not be a surprise, this is also a library that Daniel Bünzli has worked on. It's pretty good at doing these things. Essentially, BOSS provides basic and robust interaction. Basic, like the logging basic that we've seen before, so not basic at all. Pretty nice. Interaction with the operating system in OCaml. And it depends on a bunch of these other things that we've been using, like logs and formats before. So if we go into the docs, we'll see that the OS module has a file module that has a read function. And if we give it an fpath, which is essentially a path of a type that wraps a string and tell you that it's actually a path, then we just get the contents in a nice string. And that's good. Because we're checking if the file exists already, then we can assume that if we can't read it, we can ignore it. It's a bad assumption, but it's an assumption that we can make. And to do that, I would like to borrow some code that I've written around that. So I'm going to copy just this line and this line. Okay. So I'm going to go into File, and we're going to essentially add some wrappers around it that do some nice things for us. We'll add a small operator that we don't really going to use outside, and we'll make this be a string. So if we take a path and we take it into an fpath.b, this is very similar. Fpath.b is very similar to what we were looking in main. Not in this one. My bad. In here, where we said value or const. Where's const? That takes a function that you have and lifts it, puts it inside of a type that the framework understands. Fpath.b does the same thing. Takes a string and it returns you this this value in an fpath type, which is what BOS is using for reading files. All right, so now we just need to take oak and take dependencies and add some dependencies to it, like fpath or BOS, which we had before. And now we need to remove some things like base. I think this should be false. Actually, false, like that. Cool. So now the error goes back into our file, which is the git one here, and it says read file returns a string, but we expected a list of strings, so there's something weird going on here. And if we go into this read function, this returns a result of strings. So maybe it's another function that we can use that read lines separately. And this seems to have a type that is a result of a list of strings. And if you have not worked with results before, results are a type that, let's just say, not only this function will return this thing when it works perfectly fine, but if it fails, it will return something on this side, which is this will be the type of the good thing when when everything goes well, and this will be the type of something that went wrong. So if we call this function right, and everything goes well, then we will get a list of strings. But if something goes wrong, then we will get some error message. And right now, this magic operator that you see here on the right, what it's doing is it says, if you give me some value and a default, if the value is good, then I'll use the good value. But if there's some error, I will use the default. So this is a way of saying, take whatever this result is and always return a value. And it's the very lazy way of saying I don't want to actually handle this error. So if the file can be read, then ignore it and move on. Yeah, okay. So now if we go into read file, then it should have a different signature. So if we save this thing, the signature that we specify here, we don't need anymore because it has changed, and Camel is smart enough to figure that out. And now this doesn't fail anymore. Great. So if we call this thing, we'll see that if we find the file, we will find a list of strings. And if we don't find the file, we will find nothing. So now this part of the code is good. And the next thing that fails is the call to shoot ignore. The compiler is screaming that line 23 of the oak RE file, we have a value called should ignore that is not present. So let's actually, let's define it. So we'll do should ignore, and this thing should take some paths, and then it will take a path. And what it should do is it should make sure that the path, it should return what yes or no, to whether this path should be ignored. Yes. Okay. So we have lists, and we need to make sure that we find something in the list. Because the list of gitignore files is normally small, short, it should be okay to go through it over and over again on every folder. Normally you will have more, that's just an assumption that you will have more files than you have folders, but that could not be the case. That it could be the case that is not the way you store things. But anyways, what we want to do is we want to go through all of the things that we have in the list, and if we find it, then we want to return true, and if we don't find it, we want to return false. And I think there is a function for this in particular called member or mem there that will do exactly that. So if you think about it, mem is pretty much should ignore, but with the parameters turned around. So this will be the path, and this will be the paths. If we save this, then that's pretty much it. This is our should ignore function. It takes a list of something and one of that something and returns true, which makes me think that maybe we don't want to encapsulate it in this way. I don't know. I guess yes, otherwise we'll have to do paths here and make a function that calls list mem with paths at the end. Okay, yeah, this will read good enough. All right, so now the next thing we need to do is make sure that ignore gets called on every iteration. But before we do that, let's actually print out the gitignore file. Let's actually log that, hey, we found the gitignore file. We're gonna ignore this variable, right? And we're gonna ignore the variable, and we're gonna print out the lines that we found in the gitignore file. So logs.debug, if you're saying debug, then we're gonna be showing the whole file, but maybe logs.info could be like found. Maybe we could just do a switch here and say switch ignore file. None. If we found no file, we can just say could not find ignore file in, and this should be the, I guess, the path. Sorry, I'm drawing blanks. And if we found some file, we don't care what the contents are. We're just gonna be like found ignore file in path, right? So that will just print out the things that we found. And then if we're running in debug, we're gonna be showing the whole file. And to do that, we can we can take, we can switch again. So when we didn't find a file, we do nothing. But if we did find a file, we get the lines here. So we can quickly just concatenate all of them. String concat, I think. It takes a list of strings. Yeah. So we'll concatenate all of them with a new line. Lines, and then this is the thing that we will be printing. So something like that. Okay, so we have a small error in our main file. The oak.file got moved away, which makes sense. And Dune does something for us here. Oops, sorry. What Dune does is that whenever it finds a file, a module inside of your library, it will automatically make it available inside of it, but it will not export it for you. So in our module file that has the name, same name as the library, we need to export it again. This is so that we can control what we export and what we don't export. So in our oak file at the beginning, we can just say there will be a module file, which will be equal to the module file. This is very similar to the exports, some name like everything from file.js. It will be the equivalent. Okay, so that means that if we run this thing, then it does that, and then if we run on the top level, it does a lot of things, right? But if we do verbose, the first thing, oops, sorry, I'm going up. It says that it found the file, so now we need to do verbose, and we need to debug, and hopefully it will be printing out the things that we're ignoring. And it says, okay, there's a lot of logs there. Found ignore files in, nice. And then it says that it found an ignore file and then just lists the contents. So maybe what we want to do here is just log each one of these lines separately instead of all together. But I'm just gonna add a new line there, and then I'm just gonna say git ignore contents. Cool. So now we know that we're logging everything, but we're missing some things. We're missing a few files that we should probably ignore, and we can encode that logic inside of this thing. So whatever paths you give it, we're gonna add .git in there. So let's gonna call this git there. And we also wanna ignore, what else did we say we wanna ignore? Right, we also wanna ignore git ignore, right? And because this will always be at the top level, then we expect them to just be like this, in this shape. Cool. So now we can actually make this thing filter those files. So we'll just pass find all and ignore function. And then we need to refactor the file so that this thing will actually take first an ignore function, right? And then it will take the top level directory. So we remove the signature so that the language just figures out what exactly we need by default. And then what we will do is we will do switch. Well, I mean, we can do an if as well. If the ignore function on dir returns true, right? Then we'll just return an empty list. That's our base recursion case. Otherwise, we can return whatever this is. Cool. So now if we go into into file, we'll see that the recursion case has changed. So now we need to change how we call ourselves, which means every time we recurse, we need to tell ourselves, hey, this is the ignore function you should continue to use, and so on. And I think this should be about it. Now we need to change how we're using this thing by actually passing an ignore variable, which right now is underscore ignore. So if we remove that, I expect this to type check. And if we run this, I expect this to ignore the git folder and the build folder and the Merlin file. But I don't know. What do you think? Do you think you'll fail? Oh, damn it. It failed. Why did it fail? I think the reason it failed is that if you see all the paths here, they begin with dot slash. So maybe we need to actually use dot slash here. But wouldn't that mean that if we go into a different folder like source, things fail? I don't know. This seems broken. Okay. Oh, right. We're not telling it to use the git ignore. Interesting. Let's return a little bit in the past and use git ignore. And if we run this, then I think we see just as many files. We see the git ignore and the git, which is bad. We don't see anything. Oh yeah, we see everything inside the git. Okay, so that sort of tells me that the ignore path, even though it's reading the ignore file, right, is not it's not really matching on these things. So a quick check would be if we add these two things, then we should get two results less, which means the git folder should not be shown, everything inside of it should, and the git ignore file should not be shown, right? So if we run this thing here, then we'll see that, why don't we have anything from git? Interesting. We have the git folder and we have the git ignore, but we have nothing from git. I am confused. If I change this back, run it again, then I see everything from git, but when I keep this thing there, let's add some debug in here so we know what the hell's going on. Logs debug, ignoring path, and essentially we're gonna put this in a result. That's just the name of the variable, right? And so I can say if result, then ignoring path, and then it will print out that it's ignoring this path, and then I'll return the results. What am I doing wrong? Oh, right. There you go. So what I want to check is if it's ignoring all the paths. That's our git. It isn't. Oh, of course, right. Because it is finding the git, then it ignores everything that's inside of it and it doesn't recurse. Okay, so that makes sense. But I'm gonna leave this debug here. I'm just gonna do something that looks a little hackier, but I promise it's the same, so that this gets in line in a single line. And now the next thing that I like to do is to make sure that this folder gets ignored and this thing gets ignored as well. because we're ignoring this folder, but we're not ignoring anything that's inside of it. And, but wait, is that what we scoped? I forget. If we find one, we should ignore .get. Okay, this is good. We ignore everything in it. We're not ignoring this, and we're not ignoring things listed in there. Are we though? Do we find Merlin in the sources here? Do we have a Merlin file? We don't. Okay. So touch Merlin. No, okay, so this is here. And I think the reason is that our dot files normally will just include this part without the path at the beginning. So whenever we ignore, we need to take that into account, which means we so we probably want the base path to see if the base path is a member of this thing. So file name dot base name is inside there. Then that should mean that yeah. No, why? Okay, I'm clearly just jumping the gun on stuff. And it's getting a little late as well. I figured that some of you might be tired of hearing me talk. Um, so I will jump straight into the more complete solution, which I think will actually be easier in this instance, and is that whenever you list something in your git ignore, normally like .merlin, right? You want to imagine things that will have this at all. So you want to match on hello slash Merlin, but also on Merlin slash hello. And we can very quickly verify if that's the way the Git works, and if it is, then it will be a useful way of building this feature. So if we go to temp, we can just git init the repo. So we're going to a temporary repo, and we can just open the file, git ignore, and we'll say hello, and when I ignore hello files, right? So we can say touch hello, and this should be ignored, and we make their files, and we touch something inside of hello there, right? So that we have these files. Then Git should be ignoring both, and that makes sense, right? You ignore everything that has hello in the path. So I wonder if we make a directory called what hello, will the directory be ignored? And it appears that it does get ignored as well. So it seems that anything that matches, anything that has that word in the middle somewhere will not be matched. So this is a file that's nested, a file at the beginning, and then a folder. All of them should be ignored whatsoever. So if I'm touching a what nope file, then you'll see that now we get there the ignore and the what. So if I add both of them, and this is just git add all, then it's only adding git ignore and what nope. So I'm expecting everything that you put in your file to be used in some sort of regular expression where whatever is in the beginning or the ending, if you match any of these things, then yeah, it's a yes. Which to me means we should not be using list member. We should be actually doing something a little nastier. We can fold across the list, which would be a nice solution, but we could also have a reference, a mutable result. I think I'm just going to fold left. And to do that, I'm just going to say the function will be the result. And then this will be a path A. Let's call it path prime. Actually, we can call it pattern. And before we do this thing, I'm going to put that there. And patterns. And we're going to build expressions with each one of these patterns. So we want to map, and we want to do str which is a module for dealing with regular expressions, and then we have regexp. It's a function that if you call it with a string, it gives you a regular expression. So in our function, we want to essentially take a look and say match, first match. What was it? Match beginning, match ending, match string. No, it's something with global replace, global substitute, last cars. Let's look for something that returns a boolean. String match. I see nothing that returns a boolean. All right, I thought this was gonna be better. String partial match. Okay, string match. We have a function called string match that takes a regular expression, a string, which is our path, and then it takes an integer. If we go into the OCaml docs, which I already have bookmarked here, we can go into the str module, and it should be a string match function. And this tests whether a substring of s that starts at position start yeah. I don't see all right, string partial match. Return true if the argument string is a prefix of a string that matches. This includes the case string match. Okay. I'm not sure I understand how this works, so let's take a look at the. Let's try it out very quick on the terminal. So if you go into utop, which I think in this occasion we haven't done much, string match, and this should be regexp like Merlin, right? And the path should be Merlin, and then we do 0. Oh, my bad. This is not recent syntax. This is OCaml syntax. Instead of commas, we have spaces, and we have no braces around. That's exactly what I'm giving you. I'm giving you. Right, my bad. Parentheses go the other way around. And I think we need to load str. Use str. Oh, we have it there. Huh. Does it say anything here about using the module? Nope. Utop help. If you tell me how to load a module, then I will happily add that module. Huh. Okay. All right. So I'm not entirely sure how to try this out on the REPL, but what we do know is that we could try it out right here. So if we take this list, right, and we begin with false, then we can do the new result or false. or the one that we had before. So if we any of this happen to be true, then the result will be true. This it should be a boolean, right? But if any of these happen to be is not true, it will be false, and then the result will also be false, because false or false is also false. Okay, so if this compiles, or as soon as this compiles, okay, and this is line 21, path is a string, but result is a bool. All right, I'm missing the last parameter. We need to give it the path. No, sorry, we need to give you the patterns. There you go. So now this says that we're missing a reference, so the compiler needs to know that we're using the module str. And if we do, then it builds, and now we can run this thing and see what happens. And this did not work as we expected, so I think we want to try string partial match, which we have the same signature. So if we run this again, wow, this actually didn't return anything. It was true for the whole thing, which makes me curious. Anyway, I think that even though we have not managed to get the ignore functionality working, the bulk of what we wanted to do, which was adding arguments and being able to consume them in a type-safe manner from within our application, has been done, has been resolved. We can add more. We can definitely modify the app to use the level and use git ignore in different ways that are more not only more efficient but also more let's say flexible as well. All in all, I'm actually kind of okay with the way the application turned out. We have, of course, some errors here and there, but they're not huge, horrible, monsters that we want to kill. We managed to change the verbosity and have even aliases for different verbosity levels, like debug. We can use oak in any path that we want, anywhere. Let me just fix this error that's really bugging me. Line 18. What are you talking about? Oh, it's a success. All right. And that means that our application sort of does the thing that we want. Hopefully, you'll be able to go out there and just download Cmdliner and start building your CLI tools that run natively and for all of the things that you're working with. If you need any help, feel free to reach out to me and go into the Discord channel for both OCaml and ReasonML. I think you can go into reasonml.chat and ocaml.chat as well. Reasonml.chat is the forum, and in here you will be able to find a link to the Discord channel. And if you go to OCaml, I think it's discussed.ocaml.org. It's the exact same forum, but for OCaml, there are Discord channels where you can go into as well. And you can reach out to me on Twitter as well if you want. But yeah, I'm going to be posting all of this code inside of this repo in Oak. So let's just do a commit right now. We're going to do git commit add everything, and we're just going to say commit. And add command line flags or arguments. And I'll be, don't look at my password, pushing this thing out. And I will be installing it locally. You can install it locally by making running make build install. Okay, what else? I always forget to either thank someone or say something important. Thanks Universe for sponsoring me with water. I love it. It's so tasteful, and it's about 70% of my body. Water, drink yours today. Mostly free in some countries. And If you like this stream, just go into Twitch and leave some comments, leave a message, follow me. Take a look at the past ones in videos and subscribe to new events in the events section. If you like the way I write code or explain, I'm on GitHub, and you can take a look at some of the tools that I've been working with, like the Okami documentation generator, for example. And if you like what I have to say, you can follow me on Twitter as well. I don't really know how else to say this, but thank you so much for everyone that participated in the live stream. Thank you for all of the comments and the corrections and questions and the input. Thank you, Daniel Bünzli, for all of the good software that you write. It's really good, like with an uppercase G, like a noun, good software. And I will see you very soon for some more reasonable coding. All right? Thanks again, and stay reasonable. Take care. Oh, yes, and have a great holidays, all of you. Bye-bye.